Sure.
All right, we are live. Hello, YouTube. How are you? How are you, Ben, my friend?
I'm well. I'm all the better for seeing you and chatting with you.
Oh, cool. It's Friday.
Thank God.
So,
So, yeah.
well, we don't have big topics to talk about today, but we've got some small ones, I'm thinking, and maybe check in with the status, how you're doing with one of your projects using your CAD station. Tell us what we're looking at here in the lower left corner.
This is some. I'm finally making some good progress the last couple of weeks on my FPGA slash ESP board design that I'm doing. But this also raises some things I wanted to ask you about and sort of almost treat today's stream as a bit of a live mentoring session, if you don't mind, because
Sure.
this thing I got the germ of the idea of this product came about more than a year ago when I was feeling like I was missing doing FPGA design.
Okay.
So I'll share the story. I was on summer vacation or just about to head into summer vacation, and I was quietly lamenting the loss of the FPGA design capabilities in my former employer's product, because they cut it out after version 17, and version 18 it was all gone.
Right. Right.
And I honestly went to that company in 2004 because of the FPGA and embedded aspects of the overall design suite ECAD, like to have awesome schematic PCB signal integrity, but also be able to program in VHDL and do schematics for your embedded programmable logic and do the coding. All of that was super appealing to me. I just thought at the time in 2004, I thought, like, this is the way engineers are designing into the future with
Right.
every product you buy now pretty much has a microcontroller in it. And so and almost every electrical or board layout engineer I know also does some embedded development, at least a little bit, at least enough to bring up a board, right?
Right. Right.
If not, like, I know you've done that many times, although you probably prefer now to solicit the help of someone who just does that all the time, because you keep saying you hate software. But so I was feeling nostalgic, and I got onto the Lattice Semiconductor website because I'd remembered listening to an episode of, I think it was the Amp Hour with Chris Gamble, and his special guest that day was the guy who'd made a really affordable, small, super compact development board with a Lattice FPGA on it. One of the smallest ECP2s, I think, at the time, and they were selling like hotcakes on Tindy because Lattice makes these great FPGAs, but they're super affordable compared to equivalent capability in a Xilinx chip or an Altera chip. There's nothing. I'm not knocking them, but
Right. Well, Altera and those chips, you can almost double the cost of your project just due to the flash memory you have to put with it. I've done a $5 Altera chip and an $11 flash memory that went with it. It was like, wow, I'm breaking the bank here.
It's crazy. And Lattice did the right thing for the customer, and made those crossover devices. So they took their biggest CPLDs, made them bigger, and they're flash-based, so they're instant on. But I think really under the hood, I haven't looked into the silicon. I suspect they're actually RAM-based FPGAs, but they have built-in high-speed configuration or something. And then that's the Lattice XP devices. So I thought of using them because they're super capable chips,
Right.
and they're self-configuring, or
Right.
instant on.
Right.
They say instant on. And then I was looking on their website and found actually these Mark XO devices, and they're up to Mark XO3s and XO3Ds
Right.
now, which is
Right.
sort of the next tier down from the XP. They are still really have a lot of logic space on them. And if you don't need DSP, if you don't do multiply accumulators, if you're just doing a whole lot of muxing and configuring and doing state machines to do
Gates.
things like if you just need gates and state machines, they're perfect. And that's how they're marketed. They're marketed because I was thinking, well, I don't want to do the whole thing in an FPGA. I want an FPGA to make parts of it easier, because the germination of the idea is I want a TFT panel. I don't need a GPU or a heavy SoC chip that's going to be hard to get data sheets for. I want to do something that's completely open, that anybody can develop code for it and do something fun. And so I decided I'm not going to try to do anything with a chip that has a GPU. I'm just going to do 2D acceleration. What does that mean? It means you have plenty of memory to store bitmaps and images in, and enough memory that if you want, you can do 2D acceleration by just having sprites and different, if things rotate, you can have a bitmap for each angle of rotation, just like programmers of games in the 80s with the Commodore.
In the old days, yeah.
That's exactly.
We gave the illusion of movement, yes.
Yeah, but really there were sprites, and so I thought something with tons of memory for audio, for sprites, for double buffering, so you get good frames
you
per
get
second.
rid of the glitches. Yep.
And it can take care of booting the whole thing. Well, a Lattice Mark XO2 is perfect for this, and they're super cheap. So I started designing around that, and so that's where it came from. And then later on, I thought, well, I'm going to want to. The purpose of this was to be like a smart 2D accelerated display controller that you could hook up any microcontroller to it and issue serial commands over SPI to display stuff quickly. And then I started thinking, well, I might as well throw an ESP32 on there. I got two cores with some DSP instructions, so I have some DSP acceleration there if I want it, and then I might as well throw on an audio codec. And now, before I know it, what I'm essentially designing here has turned into
like a Commodore 64.
A super advanced Game Boy, right?
Yeah.
It's small enough to be handheld, and I could put touch sensors on the side. Maybe I'm still debating whether I do that or not, but because it has a TFT touchscreen on the whole back of the board, it's going to be a nice TFT panel this big with the capacitive touch.
Yeah.
All of that goes through the FPGA, and the FPGA as a coprocessor has the ESP32, which also has the audio codec on it because it's got all the stuff built in to just do that. But it's because the scope kept creeping, and it's still creeping. Like, I'm debating in my mind right now whether I should have an SD card slot on it. I probably should have a micro SD card, because
it's easy to hook up to a lot of the circuitry you're talking about. With the ESP32.
Yeah, and so the idea is that could contain operating system, could contain different programs that it bootstraps into memory, and then whatever. So
right.
So, but that through that process, and through taking on the new job at Autodesk, it just took me. It's taken me a year to get this far in the design, but I feel like the end is in sight, because I've actually started routing the PCB. So.
Oh, cool. Well, what?
So
now that's not what you're showing here, though. This is something else, or is this that?
That's what I'm showing.
Okay.
This is the
by the way, real quick, they're talking about in the chat room here that the word sprite, and they're absolutely correct, was a trademark of Texas Instruments, And so we had to call them movable object blocks. But we all know we mean a sprite.
Yeah.
And by sprite, what we mean is a predefined object in memory. What's set, like the Commodore 64, above the other computers back in the day is we had, I forget, 8 or 16 of them, where it'd be a spaceship. And you just move the pointer to where you want the spaceship to be. And any time the raster got to that part, it would stop doing the background and start doing the sprites information. And then they might have a sprite for each rotation.
Yep.
And one of the guys, Jeff Bruette, who was in the games group, he did like Wizard of War or one of those things. And he had a little spaceship on a stick. And you could tell that he had sat there and done that and then drawn the sprite to be what all these different representations. So he had a little model and then it stuck outside his desk. And you just knew that he had worked on that software program then because of this little spaceship that we used to see outside his office.
And actually, if you search, maybe we could do this real quick just for fun. You can Google this, but a lot of those old cool games that used sprites, like 1942, 1943 was one of my favorites, you know, with the World War II aircraft battles over the Pacific. So, you know, shoot them up.
Right.
You can find websites where someone's actually extracted every bitmap from the game and laid it out on a web page, and you can see each individual one and how the whole thing was constructed graphically, and download them, of course, and use them in your own, you know, retro modern implementation.
So somebody just mentioned the sprites also had collision detection. Now, by the way, we didn't invent sprites. Atari had something called the Antique, ANTIQ chipset, and it had 2 players and 2 missiles. So you would have 1 player and a missile for it. And there was, I assume, collision detection. We just blew them out of the water when we did 8 or 16 or whatever the number we did. I don't know if you've seen, there was something called a DTV, which was the joystick that was a Commodore 64 done by Jerry Ellsworth.
Yeah, I remember.
Well, Jerry had asked me
great stories about that.
Yeah, well, I screwed something up in that. I didn't know it till years later. She had asked me how I would do sprites and on that. And I said, well, I would use an RS flip-flop, and and she said, what do you mean? So I sat in a chair for 3 days and did a whole sprite engine. And I sent it to her. I said I would do it like this. Well, she sucked it into the design, unbeknownst to me. But I think I made a mistake in that if I didn't do collision detection taking into account transparency, meaning I would detect on the edge of the cell. And again, I was just doing it as a mock-up.
Yeah.
And you're actually supposed to do the collision on the first non-transparent part of the sprite.
Yeah.
Not, you have to throw out the transparent part.
Yeah.
So they actually changed the software to do it, to make up for my mistake. And you can do that when it's a closed system. They had redone all the programs that were built into the stick were adapted and licensed to be in that.
Yeah.
So they didn't have to work with an infinite number of programmers like we did back in the old days.
Yeah,
so, by the way, hi to Christian, a new person with us, Christian Iverson. Hi, Christian.
Hi, Christian.
So, I'm sorry. What were you saying?
I was just gonna say a hardware collision detection system would make sense to be on the edges of the cell, because it's just, are these two things getting to the same address, basically?
Right.
And and I'd say for all those old low resolution games, it was probably perfectly adequate to do something like that.
Right. Right.
We'd expect more detail now. Yeah. So interesting.
And one quick, I was going to say one quick story is, back when they did the VIC chip, they didn't have electrical rule checks that interface to the design rule checks. So they would hand check these chips. They would sit down at a big piece of Mylar with, I call it a ruler, they call it a scale, and they would actually measure the gates and the overlap of the gate to the channel and check their transistors against a schematic. And it was all hand checking. An engineer could be brilliant, but then he was expected to spend 3 months hand checking his chip. Well, the guy who did the sprite part of the VIC chip was legendary, because when he left Commodore and came back, and the first time he walked down the halls, I'll think of his name here in a second, and not Andreas, but the guys behind him were going, "That's him. His sprite stuff worked on the first try." So that was his claim to fame, was if you look at the Vic chip, a huge portion of the chip is due to the sprites, and he got it right, you know, in the days of hand checking. So Incredible. It was actually very cool. Yeah, he was.
He must be someone with.
Whoop, I lost you there. So we're waiting on Ben to come back. Hang on. So while Ben's out, I'll tell everybody that I've been hanging around the Nibbles and Bites. Whoops, there he's back. So Ben, I was just talking about Nibbles and Bites. I posted a link to the Discord channel while you were frozen up there. June over there is doing a mini C-128. It's about this big, and I actually got kind of a chill when I first saw it because it looks like a C-128D, my favorite model. Only it's a little tiny thing, and it's big enough to house, like, looks like two Raspberry Pis or something in it. Yeah. So
is that
drop on over there. I think it's Raspberry. They're running Vice, whatever Vice on it. But they're doing cycle, trying to be cycle accurate, which is what way more than just a software emulation is supposed to be. Yeah, so they're asking me questions I haven't thought about in 35 years, quite literally, and I'm this close. No, I'm not that close. I'm that close to actually throwing a 128 on the bench and throwing my logic analyzer on it to see if I can get an answer.
Well, you should be doing that right now on the show.
It opens up like an old dusty chest, you know. And what was that old Saturday Night Live where the guy was playing Spock? And he's talking about he was in a too small of an attic and he kept bumping his head and there was dust everywhere. That's what it feels like when I go back into my memories of how this stuff worked on. It's like as seen through the eyes of a maniac 35 years ago. And it's like, how do I remember this without reliving it? It's type of PTSD, you know?
Yeah, well, we can't have you.
No, you can't have me fritzing out. I have bills to pay. Yeah, I have bills to pay now. I can't just go on a bender for a couple weeks like I used to. But God, we had fun back in the 80s. Anybody that wasn't part of the 80s, you don't know what you're missing. Missed, I should say.
Yep. There was arguably some of the best music in the 80s too.
I've been watching on YouTube. I've been watching YouTube TV. And now I can't remember the guy's name, but he does a series of music. He's a music producer. If I think of his name here, I'll throw it out later. And he is talking in depth as a music producer about why the music in the 80s had so much going for it before the days of auto-tune, before the days of these automated copyright where it goes through and detects the part of your songs and say, you just stole a part of the song belonging to Queen or something like that. And the freedom they had and the depth of, I mean, he went into how Boston, just how the tracks were laid down and how this guy had this amazing power when he jumped up an octave and a half and could still hit the B note and stuff.
Yeah.
And it was really good stuff. I'll have to post a link to him because if you're into music, you know, this guy can hear portions of half steps, right? He's got the ear where he can sit there and listen to music and tell you, well, that's a D sustained 12 and stuff, you know. It's, which there is no such one. Yeah.
Yeah. But so something about that was, if you go back and listen to some of those, the production quality was pretty awful.
His name. Mike just posted. Rick Beto is his name.
Yeah.
Go ahead.
Yeah,
I'm sorry.
I've heard of him. Yeah, the production quality sucked. If those musicians went back and re-recorded anything in a modern studio,
right,
with the same level of skill, they'd have to practice like they did then, because no repair, no overdubs. If they got into a studio with a good analog console and digital recording, and redid it with all the headroom of 32-bit processing,
right,
and had it mastered for modern high-level, streaming formats, those would be hits again all over right now because they wouldn't sound old. Good songwriting is good songwriting. Doesn't matter when it is, and and a lot of the songs we hear now are, the production's changed things because of stuff like auto-tune and different effects and whatnot. And so that has created different genres of music that didn't exist. But
Right,
if
right.
straight up rock and pop and metal is recorded now, like redone, and you can see this with some of the groups now that do covers of old songs, it's just doing the same thing but in a modern recording studio with modern
Right.
mastering. The whole thing comes alive and sounds like it's just as fresh, if not more so, as any other brand new piece of music. And I just think it behooves some of those artists who are still around, because a lot of them don't exist anymore, but who had some good stuff, should get in the studio and redo some of it, with a modern sound, because good songwriting's good songwriting. But that's just my opinion.
Right. Vito talked about how to get a contract back in the 80s, you had to be able to do it live as well as in the studio, and that'd be part of their test. We need to see it, whereas nowadays you
really,
could go live.
Changed all that.
Yeah, you could go live and have some tone correction on auto-tune on it.
Well, they just do it. They mime and dance live.
They certainly did, yeah.
That's one of the things that I love metal mainly as my favorite style of music, and hard rock, but one of the things about it that I love is that it still tends to be done completely live. So a lot of bands have tracks to augment the experience. They'll have sound effects and partially record things, but the musicians on stage are actually playing their parts. The singers are actually singing, and they can be off pitch a little bit, or they could have a bad night.
It gives it depth. That's part of what he talks about. The chorusing is so much deeper and richer when you have That's why you have 3 piano strings in a piano. 3 strings for a note is you get something a little high, a little low, and then right in the middle, and it gives you a richness.
Yeah. That's why you have however many violins in each string section in an orchestra, is for the same reason.
Right.
It's,
yeah. That was something I did back before I tore a finger off my hand and stopped playing the violin. Was about 10 years ago, I was real hot on real-time VSTs, right when the virtual instrument, which can be different effects, didn't have to just run on a playback. I could play on my violin and do chorusing live. So I'm sitting here playing a violin and I'm hearing a chorus of like 4 violins, and it was ultimately very cool, because then I could step on it and do, because as if you haven't practiced in a while, your vibrato gets weak, your muscles in your wrist just get weak. So I had a foot pedal for vibrato just to cheat. It was like a bender bar for a guitar, only it was for my violin.
Like a Digitech whammy pedal?
It was tremolo, basically.
Oh, a tremolo, yeah. There you can get a whammy pedal, which is a pitch shifter, and I had an original whammy pedal in 1993. I borrowed $150 off a school friend to buy it used, and
that was a good friend.
This was before anyone knew what this was. $150 in Australia, so equivalent of about, at the time, $75-$80 US.
Yeah.
Dirt cheap, because they hadn't sold well and no one really knew what they were. Well, guess what happened then? The
whammy pedal.
The whammy pedal was then picked up as an obscure thing that other people didn't have by Joe Satriani, Steve Vai, and what's the song? I
always thought the whammy.
Saying Mark Tremonti, but it's not Mark Tremonti. That was Creed. It was that crossover rap / metal that came out in the mid '90s. Oh my gosh, why am I brain farting on that?
Because you're getting older. I'm already there, so you have my sympathies.
They told you. You know that song.
Yeah. Now, didn't the whammy pedal, didn't it do other things? Like, didn't it have a volume attack or a phase shift that went in with it, or was it just pitch shift?
Just pure pitch shifting. So you could play a note and step on it and go up 2 octaves, down 2 octaves, harmonize.
I was gonna say it sounds like a filtered harmonizer. Yeah.
Well, it's a pitch shifter. So
Right.
So it would take your incoming signal and FFT it, shift the spectrum, IFFT it, and spit it out. Something
Right.
like that.
Right.
Also called a phase vocoder. But those became insanely popular because of those popular musicians. And then suddenly on eBay and now on Reverb, there was a time where they only made so many, and people wanted the original version. They were selling for $1,000 used.
Wow.
So yeah, I was kicking myself for getting rid of the one I had back in the day because I could have made a lot of money on it. But anyway,
you know what though? If you plugged it in now, it'd probably sound noisy and all kinds
no,
of.
I got one again later, and they were really well designed.
Okay.
Super well designed by
I remember doing
team up in Canada.
I remember doing pitch shifting using the old the bucket brigades. They were the CCD bucket.
That's a real old way of doing it. Yeah.
And they were just noisier.
They would be noisy. Yeah, they were.
Yeah.
Yeah, because what you do is you record a wavelet and then you play it back at twice the speed to get an octave higher.
Right.
But you have to play it back twice because you now
have to invert it on the other way down. Yeah.
But by playing it back twice, there's no even start and stop points on a actual waveform. So the key IP in the Digitech whammy pedal was that it had zero crossing detection on every waveform, and they would vary the window or wavelet sample size to match up with a whole wave of the instrument's signal, and then splice that and then blend it in so that you didn't have any glitching in the or less glitching. It was still glitchy, but yeah.
Well, I remember Insonic was one of the people that did early. They used this technology called an EEPROM, and they stored quarter wavelengths of different sources in an EEPROM and scanned them, inverted them, and scanned them forward, backwards, inverted.
So I don't know if you have a notepad and camera view there, but why do you only need a quarter wave?
That'd be hard to draw and show. I'd have to, but essentially, if you do a quarter of a sine wave, then you just clock it backwards, and there's your decrementing value, and then you invert the polarity, and now you're going negative, and then you invert the polarity and the clock, and it gives you the last tail. So a sine wave is the same portion folded and reversed.
Yep.
So it's pretty straightforward.
So if you want to do DDS, that's how you do it.
Yep. And then they replaced EEPROMs with a RAM, and we got sampling keyboards where they would try, as you said, you had to have your zero crossing down, and you had to be able to sample the sound either at a macro level or at you know what? Now that I think about it, I don't know that they did a wavelet or quarter wave, but they replaced an EEPROM with RAM, and the sampling keyboard was born.
Yep. That's because, and that's when they put floppy disks in those things too, to store all your samples. Yeah.
Right.
That's what happens, when memory gets cheap, you start wasting it because you can, and it makes everything easier.
Right. So I remember watching a Peter Gabriel concert, and I think somebody kicked the power plug on his Korg on stage. Dang. So they had to stop, and he's telling us he's watching the Korg reboot in front of an entire stadium of people, and he goes, "Oh, now there's a happy little he's talking us through the Korg rebooting so that he could finish the song." And it was like one of those moments.
Good entertainers will take any situation and make it fun.
Or die trying.
Their crap,
Right.
Yeah.
So back to what you're showing us here. Is the schematic for what you've been talking about?
Yeah. So I think I showed this one other time. This section here is my JTAG, and I think the direction I took in the end was what I love about these FT2232s, the Universal Serial and JTAG chip from FTDI. The point is, if I'm just having one JTAG chain, I can have that on one side, and the other side can still be a virtual COM port, which is really useful for the ESP32 because the ESP32 can boot off of that. I can download code to it using the normal serial connection that the bootloader uses, and it's also a serial interface over USB after the whole board's brought up and is running whatever program. I've got a USB connection to a host to download other programs or interact with it in whatever way I want.
Right.
So then, and then last time I did show the audio codec, I had a concern about using these Wolfson Micro 8731s. They're very popular and super cheap. I got a bunch of them off Alibaba. I assume they work, but we'll see. What is obscure about these codec chips is they have separate left-right clocks. Now with I2S, and we've talked about serial interfaces before, right? I2S uses a master clock, which is one clock pulse per bit of data for the serial interface. You have a serial data in to the codec, a serial data out from the codec, and each bit of an audio sample is sampled on the bit clock or master clock. So that's B clock. But then you have another lower frequency clock that's synchronized to the sample rate. So at the most significant bit, at the beginning of a packet, you have the right channel data, and the LR clock goes, I don't know, low or whatever, and then it stays low until all 32 bits or 24 or 16, depending on your resolution, and any padding gets clocked in with the bit clock, and then it toggles to get the left channel. So it goes right, left. So that's called your, or left, right. So that's your LR clock. And normally in an audio codec, you only have one LR clock pin. But this one, this Wolfson Micro has separate D to A converter LR clock and A to D converter LR clock, which implies that you can have different sample rates for input versus output of your codec. So I could use this Wolfson codec and
a converter.
I can have a microphone with a telephone sort of bandwidth coming in and an 8 kilohertz sample rate for the input, but be spitting out still a 44.1 kilohertz sample rate for the output, for example. And so it's kind of flexible, but it wasn't clear. I read the whole data sheet. It did not say what to do. With most microcontrollers, the I2S interface only has one LR clock pin. It assumes if you're in full duplex mode, you've got the same sample rate for read versus write. And the data sheet didn't say what to do. And I'm like, geez, this is a problem. I don't know. I'm not going to.
Do you hook them together or what? Yeah.
Well, I found some other reference designs on the web. I found there's a synthesizer module manufacturer called Mutable Instruments and all their designs are open source, which is awesome. And they design their boards in Eagle. And so I was able to open up one of their synth modules that actually uses this chip with an STM32 microcontroller for that synth module. That's pretty much the core of it. And they just tied the pins together. It's just like if you have the same sample rate for read and write, just join them together, and that makes obvious. It's so obvious in retrospect, but the data sheet wasn't explicit about it. So I got that done, and then.
Would you call those different sample rates or different clock domains? Chris from the chat channel called it clock domains. To me, it's a different. Well, if it's a sample rate, that infers a buffering in the middle that makes up for the.
Well, they share the same master clock, and everything is synchronous to the master clock. So it's one clock domain. And that's the master clock in this chip. It has its own master clock, which is this crystal here. And from this 24.576 megahertz crystal, you can derive all the standard audio frequency sample rates for 8,
So it's
11,
not true
whatever.
asynchronous clock rates. They are related to each other.
They are synchronized, but the LR clock can be slower on one port, can be at a different sample rate, but they're edge aligned. They're synchronous to this B clock, which is your master bit clock for the serial transfer on I2S. So it's one clock domain, but multiple clocks.
Right. Okay.
And a different clock domain is it's gone through a PLL and it's a completely different frequency that's not synchronous to the source, or it's two separate oscillators.
Right.
If that makes sense. Yeah.
Yeah, well, that to me implies a true dual port RAM in the middle then, because then you need a way to clock into some kind of storage and clock out of it in an unrelated way. And that to me sounds like a dual port RAM function. And
I don't know the internal workings of the ESP32, which is hooked up to this for the I2S interface, but the ESP32 and any microcontroller that has an I2S port will be a slave to the converter. And that means you do have different clock domains. So the codec clock is completely free running and separate from the microprocessor in the ESP32 module. And so they must have some kind of clock domain crossing and synchronization. But it's generally pretty safe. This is one of the reasons why we like. Did you lose me?
Yep, you're back. You're back.
I was going to say this is one of the unspoken or maybe fringe benefits of serial transfer between devices on the board, and why I like serial interfaces, because you can have a serial receiver that's clocked by an outside device and is completely independent of the rest of your CPU that is a host to that peripheral. And then what happens is asynchronously, the other clock domain, the codec, finishes its transfer, and this peripheral initiates an interrupt, and that interrupt bit flips on its own time. But because that happens, once that interrupt is flipped, it's locked in the whole thing, and the received data is clocked through, and it's all locked in a register that the CPU can then read and clear at its own leisure on its own clock domain.
Right.
So it's like there's this ship floating on the ocean, and it comes into dock, and then once it's fully docked, the dock hands can tell the cargo crew, okay, you can come get the cargo now.
Time to come,
And then it's up to the cargo crew and their own timing when they do it. It's exactly like that. So that overcomes the problem of crossing clock domains. And so serial interfaces are really good for that.
Cool. Hey, so what CAD are you using to show us here today, for those that might not be familiar?
This is Fusion 360. So it has its... Fusion 360 started out some years ago just as a mechanical modeler. So it does all the 3D modeling, and then Autodesk.
We lost Ben again.
I'm here.
You're back.
Hello?
Yep. You're back.
Yeah, sorry about my AT&T doesn't like me, even though I'm less than 1,000 feet from the box. So annoying. Anyway, or maybe it's Skype. Yeah, I was going to say, this is Fusion 360. So Autodesk acquired Eagle maybe 5 years ago, and they kept that going.
Has it been that long? Yeah, wow.
Maintained it, added features to it. But the long-range plan is to bring ECAD and MCAD together in one platform, so you can much more easily. So imagine I have designs with potentiometers. I can actually make my potentiometer in the CAD library for electronics. So when I place it there on a board and then go to an enclosure, it can automatically cut a hole in the enclosure for me right where I put it. And if I move it, the hole will move with it, right? So that's the kind of we should have been there years ago, but finally there's a product that can do this kind of thing. It's Fusion. So
Wow.
I came to Autodesk to be the product manager for the ECAD in Fusion, which has its roots in Eagle. So if people are familiar with Eagle, and a lot of people are, a lot of people have used it, you'll be pretty much at home in Fusion doing electronics. Eagle's still there, but Fusion is honestly the future. So
does it support ULPs
yes.
like Eagle used to?
Yeah, ULPs and SCRs, you can automate it, but Fusion has its own Python scripting engine. So eventually the whole thing will be accessible at a higher level through the Fusion Python API. And so you'll be able to automate not just the ECAD part, but maybe the entire parts of the workflow.
Right.
But the value is you get, here's my PCB. I'm still working on the routing. And the routing in this is actually really awesome. I've only really just got started, but it's right up there. It's a powerful routing tool.
Are you able to do group route like Altium always shows in their promos?
Yeah, all of this stuff around the top of the FPGA and the LCD, the touchscreen connector for the graphics, all that was just routed in 2 seconds by selecting the nets and saying route them, and it just goes bam, does it. Right. And you can guide, it does all the same sorts of things. It's called Quick Route, and it's actually, it's very powerful. You can guide it if you want. The first product to offer or demo something like that, I think, was Mentor Expedition back in the day. But Mentor Expedition, only the largest companies could afford it. So
right.
This will work even in the free version. Also, like Eagle always had a free version with a limited layer stack and board size, and it's the same limitations for the free version of Fusion. You can still design boards that are within a sort of certain size and up to 4 layers, I believe. And all the routing and everything, like the features weren't taken out. It's just the size of board you can do. So
now, is that an FPGA that the main item there? That
so
and is that a connector? Is that a connector to its left that all the traces lead to, or what is that?
I'll show
right
you
there.
that.
Yes.
Well, you can see that in the 3D view. So this is the benefit of having it all in one tool. Now I know Altium and other tools have, even KiCad has some 3D view capabilities, but this is an actual 3D modeling environment where I can do sketches, extrude. I can add this to an assembly and do the enclosure around it. So it's not just 3D view; it's actual mechanical design. So that's the connector for the TFT panel and the touchscreen connector for the TFT panel. And you can see there, and I can move the whole thing around. See, I've left the back of the board completely blank because that's where the TFT is going to attach on the back side of the board, right?
Right. So you did a technique there, though. None of your traces from the FPGA to that connector have to cross each other. So either you pinned out your connector to match the FPGA, or you pinned out your FPGA to match the connector, I'm thinking.
And that's precisely what I did. And one of the reasons I love FPGAs is your pin out is what you choose it to be, for the most part. There are some specific special features in FPGA hardware sometimes that require you to use certain pins or groups of pins, but by and large, for general digital I/O, I was able to pin swap all of that to optimize the board routing, and that makes it super easy.
Now, did you do a true pin swap where you actually output the file as you output a file and pull that in as a pin assignment file in the FPGA software? Or did you just knowingly lay it out?
I just did it I drove it from the schematic first, or from the board actually, because you can pin swap in the PCB. So I did it in hardware first approach because I've written not even one line of VHDL or Verilog for this yet. I'm going to design the whole thing first and then build the first prototype. I actually have the exact same device on a breakout board. I'm going to do some tests on
Yeah, I
that
got one of
first.
those. Yeah.
I'm going to do some tests on that first to make sure if anything doesn't work the way I think it should, it might lead to changes in the PCB design. But I haven't got a pinout file. But I could do that. I mean, that's kind of where things like ULP scripts come in to
Right.
automate the process. And
Now, I
then,
used to do a floor planning stage. If I would do what you did, but then I would stop and go ahead and compile the FPGA a little bit to see if I'm going to be able to hold to that pinout. Because there's some times where you just can't get all
yeah,
those functions on one side of the chip, or you
that's
get
right.
almost to the end and find out you can't fit it. So you have to do some floor planning, layout, and kind of guide yourself
Especially,
through it.
yes, especially when it comes to things like DDR controllers. So on this board, I'm not using DDR, although this Mark X02, you can do DDR2 and DDR1 as well as SDR. And they have,
Okay.
Lattice has an IP wizard for a SDRAM controller that you can configure it. And it's got some specific I/O hardware that makes it super efficient for full speed DDR2 chips. I'm using just standard SDRAM chips that are easy to buy, because that's good enough for what I want for this board. And so I did put those on the I/O banks that are based on the reference designs I looked at. There were some particular I/O banks that were good for attaching to memory
Right.
for that reason. So they're on that side of the chip for that reason. And
And there's even suggested layouts and stuff from the vendors sometimes. Their app note.
exactly.
You might
Yep.
as well pin it out like they have it because you know it works.
Yeah. So here's the other cool thing. So I've got the component editor there. I've got the symbol editor and footprint editor, which people are very familiar with all of that. But one of the other things I really love about this is the 3D modeling. So I can, if I'm in a library here, I can actually start with a package if I have a data sheet, and make a new package. And this actually puts me in the 3D modeling environment, but automatically loads this generator. So this is like an IPC compliant footprint wizard, but it doesn't just give you a footprint, it gives you an actual 3D model, not just a step model,
Right.
but the actual timeline with all the sketches and extrusions used to build the 3D model, so you can change it or parameterize it. And
All right.
so I can make an LED, and I can specify the color I want. So if I want to, oh gosh, let's do a blue LED, right? I think the default size here is an 0603 package, and I can override the footprint pads and look at IPC least nominal max and click add. It doesn't just generate a footprint here, it also generates the 3D model to go with it. So, and that chip on the inside, that little chip part of that, so this transparency here is cool, but the chip inside there is automatically assigned an emissive property. So when I'm in the rendering environment in Fusion,
Right.
this will be a light source and will generate light, and I can see how that light bounces through a light pipe that I designed, for example.
Okay. Wow.
So so it's pretty powerful. I love it. But
So somebody's asking if you can import design files like Altium files.
I can't import Altium into Fusion. Well, there's a ULP that will take Altium ASCII or PCAD ASCII. So technically a two-dimensional board file from Altium you can import. Altium just released on their website a collaboration between the Fusion MCAD and Altium Designer, so you can push a board that way and get all your models in Fusion and then make your enclosure in Fusion. But even if you're using KiCad or some other tool and you want to generate step models, use this package generator in the free version, and you can actually these 3D models can be exported to step, so you can use them in any other tool. Like it's worth having Fusion alone just for generating the models for your parts if you're not also designing schematics and PCBs. But the schematic and PCB environment's also really cool. So, it's taken me a whole year because it's so different the way that Eagle works. I used Eagle back when it was version 4 when I was in university, and then I got a job at Altium doing FPGA stuff, and then spent 17 years becoming an Altium expert, and I can do anything in that tool that it's capable of doing. And then I took this job at Autodesk, so I've had to, it's like getting a new bicycle where the handlebars are geared to turn backwards. The other way.
Yeah, yeah.
And so it's taken me a whole year to detach my brain from Altium's paradigms enough to where I can start to be effective doing ECAD in Fusion. That's just me because I'm 46. You know, I don't learn things as fast as
the plasticity is not what it used to be when we. I was going to say when I was young, I knew probably half a dozen different CAD packages interchangeably. You just sit down and start doing. And nowadays it's like, you know, you talk about being able to do anything that you can do in Altium at any one moment. I only have a working knowledge of 40% of what's in Altium, and there's an additional 20% I can find. But I never really got above 60% of what the package can do at its heart.
Yeah. So even if I didn't use the wizard, it's got all the normal, you know, mechanical modeling. But what I find cool about that is I did potentiometers. I did 16 millimeter pots, which are not in the wizard, and I was able to model those really quickly. Also, some other transistors. I did.
Didn't you model an audio jack? You had a real cool model of an audio jack at one time.
I did. Let me show you that. This is not letting me save this because I've already done that before. Let me go into my library and I'll show you. Is it? I forget what I named the component.
So one of the things I was thinking about earlier when we were talking about FPGAs and the Lattice, first off, that the Lattice, you can still get 5-volt tolerant parts in Lattice, or at least you could. Whereas if you use the modern Alteras and Xilinxes, you inevitably need some kind of level conversion if you're trying to get to 5 volts.
Yeah.
I had posted a link to Alan Wolke's video where he had a little XY generator for a scope that did the Tektronix logo.
I loved that, and it did the wizard icon.
Yeah, yeah. And what I was thinking while you were talking is, you know, you could do that inside an FPGA, and it looked to me like the code broke it into quadrants so it could deal with it 8 bits at a time instead of trying to do 16-bit addition, you know, math. It looked like it said pick a quadrant, do 8-bit math while you're inside the quadrant. But if you were to do that inside an FPGA, you have both the memory and the ability to, you know, add 16-bit numbers together or whatever, 24-bit numbers, counters and whatnot to make your vector draw.
Yeah, I wanted to find these TO225 is a good one. I did that one. These are through-hole parts that are not in the package generator right now, but it's easy enough to create these. So this TO225 is a normal power transistor. So for some switching power supplies or audio amps or things like that. Now the package, I believe this is the one. You take a data sheet and you get the line drawing of the package, and it's got that JTAG standard table of dimensions with labels, right. A, B, C, D, little b for the pin spacing or whatever, and little e for the pin width. And I think this is the one. If I go to the solid modeling menu, it might have been a TO220 I did this with in another library, but
right.
Where is it?
So Frank Bus just mentioned that the 3D step models are available through places like Snap EDA and Ultra Librarian, and we're both heavy users of that.
Both of them have plugins for Fusion, by the way. So you can actually load a plugin for SnapEDA and place parts straight in your design from SnapEDA.
And Ultra Librarian has a plugin for Altium, I believe. I think that's on my menu now.
And they're building one right now for Fusion. I don't know that it's released quite yet. Okay, here it is. So there's this parameters. So in any 3D modeling tool worth its salt has a parametric. Yeah, this one isn't the one. It must have been.
And somebody mentioned, somebody mentioned that when you are pulling something from an external library, it's still on you to make sure that it's right. Just because you got it off. Yeah.
I got bit in this design because the ESP32 module I used came from, I want to say it was, I don't know that it was Adafruit. I think it was actually from Espressif themselves. It contributed a library to our library on library.io, which is a library website that all the community available libraries are there. And I copied it into my own library and didn't realize, but they'd changed the layer number.
So we're losing Ben again, but he's talking about the old problem of... Start that sentence again. You're back.
I was saying I copied their library, their footprint and symbol and 3D model. I copied the footprint and symbol from the Espressif library to my own and added a 3D model. But then in the board, there was a keep out on an internal copper layer, which was incompatible with my layer stack for this board. And I couldn't delete it, and I couldn't figure out how do I get that out. And then I went into the library. I realized it was in the library, and it could have stopped me going to Gerber. So you've always got to check everything. Pinouts can be wrong too.
And the layers don't always translate between the different manufacturers. So that's where I would get, the first thing you check is, well, did it put it on the right layer, or did it get lost, a piece of something in the layer transition?
Right.
So now
anyway,
I'm a lazy
about all that. I know we're getting close to the top of the hour already. I wanted to ask you, Bill, because one of the things that took me so long with this project is feature creep. I kept adding stuff to it, and you still have thoughts to share there, so I'll let you finish that.
Well, I was just going to show this was just real quick. I'm a lazy engineer, so there's times when I will absolutely, let me grab it again, go to Smart EDA, at least or Snap EDA type places, to at least get my project started. So I was talking to somebody about the Coral from Google. Whoops, not that one. And they got this footprint you see here on the right. And it's like, I don't want to have to make that just to understand how it's going to fit on the PC board. So I absolutely grabbed it just to show, yes, Bill Hurd can do this. Here's a footprint already. Aren't you impressed, right? But before the end of the day, I'm going to have to go in there if the project commences. I'm going to have to go in there and make sure it's correct, even though it looks... And honestly... A friend of mine can do this, guy named Terry Fisher. He lives for doing this kind of thing, I think, or he's good enough that he should. But not me, man. I'm lazy. If I can buy one of these reconfigured or pre-configured, I certainly will. So I'm sorry. What were you saying before I brought that up, though?
No, I totally agree with that. I just wanted to ask, in all your years of hardware design, how do you control, or what process do you recommend for commencing a project and actually being disciplined about not even starting something until it's really...
So we're losing you again, and you're back. So I heard the first part of the question. How do you start to commit yourself? You were asking, how do you control the process?
Yeah, exactly. And limit... put guardrails around it so you don't end up doing things that weren't scoped.
Right. And part of that comes with somebody has to be empowered to say no. If nobody in the organization can say no to other managers or other people, you can make a process that says, here's our design review process. You get us changes by now. We will open a window when you can make other changes. And if you try and make a change outside those windows, you'd better have God himself on your side, or in our case, Jack Trammell or somebody like that. But you get in other instances where everybody's equal powered and nobody can say no to somebody, and they say, I have a good idea, I insist to be in here. If his boss doesn't agree that you can tell him no, you're kind of sunk. So it's really about agreeing to the process and procedure ahead of time. And that's what I do. I say, I'm going to have a design review here. Here's my schedule here. And if you mess with me, you're responsible for this milestone over here being missed, and it'll be your name on it. I like to point at them when I do that.
Yeah. The trouble I have is all of those people are inside my head. Meaning this project is entirely on me. It's my idea from start to finish, and I can't. The CEO, the product manager, the software developer, and all the hardware engineers are all in here, and when they all can't say no to each other,
right.
What do you do?
And I walk myself through the steps of a design. There's proof of concept, and then there's an alpha unit where it is supposed to act like it, but doesn't need to have the same form factor. A lot of times it's got stuff in it that won't exist later on that you may have even gotten off the shelf. And then you get to the beta unit, which is supposed to start to represent the form factor and the function. And then you get to pre-production, and at that point, you're not messing with it, right? Pre-production, and I've heard it called, it's not pre-production in some environments, it's called something else. But pre-production to me means I'm going to make it as if it's production, which means I'm not going to be going in there and making changes at this point. I'm cemented. Or I'm going to go back to the beta stage. Which do I want to do? But I'm not going to make lots of changes and then go to production, because I haven't made a unit that I feel good about in production.
Yeah.
So I'll circle in that pre-production phase until I get it perfect. I don't. And again, I'm used to real huge productions where if you even have one little thing wrong, you'll get found out in production.
It could cost millions of dollars potentially.
Right. And the wire that we did on the C128 that we talk about every now and then, we did a pre-production type of build of 10,000. We did it over the weekend, which is a production build for other people, right? But we did it exactly as if it were going out the door, which meant it either works or it doesn't. There's no in between. Either you're passing this to production or you're screwed. And it happened to have worked in that case. So, yeah. Well, we didn't get a chance to talk about voltometers, but I've been I've been just watching my Keithley here. I'm old school, so I love my Keithley 5-digit.
It's beautiful, man.
We'll have to talk about those more. Mike Fikes just got himself a Simpson 260A, and I think he looked at Alan Wolke's video on Simpsons. Alan saw mine and that's a Series 6 or something. I couldn't remember, but my Simpson 260 is from when I was in high school. That's how old mine is.
That's awesome.
And if anybody has a battery compartment for a Simpson 260, the door, I could use one. It's actually, I think they're even up on eBay. But we'll have to talk about this later.
3D print one.
I had a 3D printer. I got a Prove It. What's the name of the?
I don't know.
It was.
I'm out of touch with those.
I donated it to the local library. I and said, here, it's your problem now, because while it would print, it would never print something completely without a flaw. And it's like, well, that's a flawed process to me. If every print, and I asked somebody that I trusted a lot, who's doing a lot of printing, I said, I can't get it ever a perfect print. And again, this is 5 years ago. And he goes, yeah, that's normal. I'm like, then what the heck am I messing with it for? Yeah. So Prussia? No, it's somebody, but I can't remember the name of it, but yeah, so now the library has my old one. So it sounded like a good idea, and I'm sure there are people that are wonderful at it. Nibbles and Bites is doing their little mini C128 as printed. She was even talking about finding the filament that replicated the old Commodore beige, which actually I had to admit by looking at the picture, the camera shot of it.
Looks pretty close.
It looked pretty close. So I actually talked with the guy who did the original Mini 64. He's actually passed away, but it was done by Commodore USA. And they were releasing a whole Commodore 64. Actually, it wasn't even mini, it was full size. And he talked about it was far harder to get the plastic color right than anything else. And that was his first thing. And then the other thing was, he said, we did a print using the old PVA print technology and tried to base our plastic. And I just interrupted him. I said, you can't do that. PVA printing is not like shooting plastic. They're the different dimensions, different shrinkage. And he said, you're absolutely right. So I had offered to help him with that original Commodore 64. You know, we're talking 8 years ago now. Yeah, and then he passed away, and it just all died on the vine.
What a shame.
I'm thinking,
yeah, that was I vaguely remember seeing that they were building a C64, but it was going to have a PC, like a micro ATX motherboard was in it.
Yeah. Well, the whole trick there is, how can you do that legally without having the rights to the EEPROMs, to the ROMs, to the firmware that sits on there? And even the font ROM, in theory, is copyrighted. So you literally have to sell it and tell people, we don't care where you get it from, but you got to go get your own firmware. That's the problem I have with
RetroPie is the same. It's like, okay, this provides you with the system to build your own retro arcade console. Where you get the ROMs is none of our business.
Right. You know, back when I was in Japan, they have an anti-gambling thing, right? You're not allowed to gamble in Japan. But they have pachinko parlors, which are big gambling parlors. Well, how do you get? Well, when you win, they give you a pack of cigarettes. Or I think I got some lighter flints one time. And you go out the door and up these rickety stairs, and this little door would slide open, and you would slide your pack of flints or something and get money back. So you won a pack of flints, that was legal, and then going next door and exchanging them for
it was legal.
Yeah, I sold them. Yeah, and then they would use them again. Yeah. So, well, next week we'll have to get into multimeters, maybe for everybody if they want to talk about what their favorite multis, because we talked about the small handhelds last time. But here's my question for everybody. Why do I have 5 connectors on the front of my Keithley?
Yeah, I was going to say, we're going to answer that question and more next week.
Yeah. So
I'll try and get my Metex branded as a Dick Smith Electronics from when I was in college. It's got an RS-232 port on it, but I need to redo the cable and hook it up to like a USB virtual COM port somehow. And I'll see if I can get that done for next week too.
And when I first turned this on, I thought it was giving me an error message. I'm like, oh great, my Keithley died, and it was actually giving me the IEEE 488 address. You know, it started with E. I thought it was an error code. I think it was like E04 is like device 4 or something. So these did have the old IEEE.
Yeah.
Yes, it's automatable, which is cool if you can get it working. Matter of fact, that's a subject of a whole nother conversation, because I got a USB to IEEE interface, and I could get some things working and other things I couldn't. I couldn't get the auto zero function to work on one of my meters and stuff. And it's like, how did they get this stuff to work in the old days? Plus you get a hell of a ground loop through your data connector. That was another problem.
Yeah.
And cool. I know that because I touched it in the ground at the same time and got shocked. So. So, all right, Ben, my friend, we will see you next week, and we'll talk about meters and other fun stuff.
Sounds cool.
All right, later on.
Thanks.